Hello guys, in this video we are going to discuss the solution of the problem max sum in the configuration. So let us look at the problem statement. The problem statement says that given an integer array A of size n, your task is to return the maximum value of the sum of I times ai for all I ranging from 0 to n minus 1, where ai is the element at index I in the array. The only operation allowed is to rotate the array any number of times, and the rotation could be clockwise or anti-clockwise. So let us try to understand the problem statement with the help of an example. So here, let us say this is the array which is given to us. So if we go ahead and take this array, and if we rotate this array one time, then the resultant array will be 3, 1, 2, 8. And once we have this array, if we go ahead and perform 3 times 0 plus 1 times 1 plus 2 times 2 plus 8 times 3, the resultant value we will get is 29. Similarly, if we go ahead and rotate this array one more time, then the resultant array is this. And if we perform the sum operation, then the sum we will obtain is 27. Similarly, we can rotate this array two more times. And in this way, while rotating, we will go ahead and compute the sum. And towards the end, the maximum sum is 29. So that is what we are returning here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of the problem, let us say there exists an array A whose size is n. Now, the elements of the array are something like this. So A0, A1, A2, A3, similarly other elements, and then the last two elements, so n minus 2 and n minus 1. So let us say these are the elements which we have. And let me write down the coefficients, also the indexes. So this is my 0th index, this is first, second, third, n minus second index, and n minus 1th index. If we rotate this array, then the resultant array will look something like this. So A0 will come here, A1 will come over here, A2 over here. Similarly, this value will be n minus 3, and this value will be n minus 2. And the n minus 1th entry will come towards the beginning of the array, which is this array. Let us go ahead and rotate this array one more time. So if you rotate this array, then A0 will come here, A1 will come here. Similarly, here we will get n minus 4 and A of n minus 3 here. And the first two elements, well, A of n minus 1 will come here, and A of n minus 2 will be at the 0th index. So let us say this is my configuration A, this is my configuration B, and this is my configuration C. So now let us write the values for A, B, and C. So if you see, A is equals to 0 times A0, 1 times A1, 2 times A2, 3 times A3, n minus 2 times A of n minus 2, and n minus 1 times A of n minus 1. And let us write down the bth value for B also. So the value for B, and let us just scroll a little bit up. So if we look closely, we realize that a 0th element will be multiplied by 1, a1 element will be multiplied by 2, a2 element will be multiplied by 3, and so on. So the value for B will be equals to 1 times a0, 2 times a1, 3 times a2, 4 times a3, and let's go further. So here we will get n minus 2 times A of n minus 3 and n minus 1 time A of n minus 2. Now let us say these are the values of A and B, and let us go ahead and perform B minus A. Now if we perform B minus A, what we will get is, so if we see these values, if we see, all these values will essentially translate into A0 plus A1 plus A2 plus A3 plus ... all the way till how much? All the way till n minus 2, A of n minus 2. So this is B minus A. And now what are the terms which are left? Well, the only term which is left is this term. So let us write down this term also. So this term is essentially minus of n minus 1 a times n minus 1. Now let us rearrange our equation. So this is essentially a0, a1, a2, a3 dot dot all the way till a of n minus 2. Now n minus 1 is missing, so let us do one thing. Let us add n minus 1 over here. And since we have added n minus 1 to the equation, so we have to subtract n minus 1 also. So let us subtract a of n minus 1. And then the remainder term, which is n minus 1 times a of n minus 1. So let us call this, so this is essentially the sum of all the elements of the array. So this is the sum of all elements of the array, and let us call this sum as S. So then our equation can be transformed as S minus, and if we solve this, what we will get is n times a of n minus 1. So this is the value of b minus a, and if we transform it further, well, b is equals to S plus a minus n times a of n minus 1. And let us analyze a and b. So if we analyze a and b, so if a is my current sum, then b is my next sum. So in a way, what I can say that my next sum is equals to S, the sum of all the elements of the array, plus my current sum minus n times a of n minus, and since this was the first rotation, that is why n minus 1. Similarly, for ith rotation, this will be n minus I. And this forms our equation. So now let us discuss the pseudocode for this problem. So let us say we want to find out the max sum. An array is given to us and the length of the array is given to us. So what we are going to do is we are going to set S is equals to 0, and this S is the sum of all elements of the array. Then we will have another variable which is equals to current sum, and initially the value is equals to 0. And then we will have a max sum, and initially we can set this value to minus infinity. Now we are going to iterate on all the elements of the array. So for I in range of n, and we are going to compute the sum of all elements of the array and the current sum. So the sum of all elements of the array can be computed as S plus ai, and the current sum can be computed as current sum plus I times ai. And in this way we will be able to compute our current sum and the sum of all elements of the array. Once we have this, what we are going to do is we are going to update our max sum, and the max sum will be updated like max sum is equals to max of max sum and current sum. So whichever is maximum, that will be our answer. Now once we have computed the current sum, now the point is to compute the next sum linearly. And in order to compute the next sum linearly, we can rely on the equation we have discussed. So I am talking about this equation. We can rely on this equation in order to compute the next sum linearly. So let us see how we can do that. So what we are going to do is we are going to rotate the arrays. So for I in range of 1 to n. So the first rotation all the way till nth rotation. After first rotation, the next sum will be equals to, as discussed in our equation, the next sum will be equals to S plus current sum minus n times a of n minus I. And then let us now update our max sum. So our max sum is equals to max of max sum and next sum. And once we have done that, now let us go ahead and update our current sum. So our current sum will become equals to next sum. And then towards the end of it, we are going to return max sum. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So the implementation is pretty much the same. So the first thing which we are going to do is we are going to compute the current sum and the sum of all elements of the array, which is this part. Once we have that, we went ahead and updated our max sum. After doing so, we are rotating the elements of the array, and after rotation we are computing the next sum, which can be computed by this equation. And once we have computed our next sum, we are going to update our max sum and we are going to update our current sum. And towards the end, we are going to return max sum. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.